All right, so now we're going to define one more term we're going to use, which is a relation on a set A. Is a relation from A to A. So now we're going to look at a few examples here. So let's start with this first one. Let's say A is the set 1, 2, 3, 4. So then R 1, 2, 1, 3, 2, 2, and 2, 3 is an example of a relation on A. So all of your first coordinates here come from A, and also your second coordinates are elements of A. So you're not really working with two sets, you're really just working with one single set A. So let's look at another example here. Let's think about something you see a whole lot in math, the unit circle. Well, the unit circle is made up of some points in two-dimensional space, or in what's sometimes referred to as Euclidean space. So the unit circle consists of ordered pairs that are subsets that contained in the space R cross R. And so we can talk about the domain of the unit circle, of the relation that describes the unit circle. Well, the domain, that's all your first coordinates, which mean all of your x values here. So my x values range from -1 to 1. My codomain, it's all my possible y values. Well, my possible y values are any real number r. But then my range, what are my specific y values here? -1 to 1. And we could call this relation, let's give it a name, C. It's the set of xy in R cross R, where x squared plus y squared equals 1. And then we have, for example, 1, 0 is in this relation, or is in, I guess I should say C here, is in C. We also have -1/2 square root of 3 over 2, that's also in C. And so C is an example of a relation on R, on the real numbers R. Let's look at another example of a relation on a set A. Now my set is going to be the integers, so I'm going to look at a relation which needs to be a subset of z cross z. And I'm going to say that AB is in the relation if and only if A is a factor of B. Another way to say that is that A divides B, which symbolically we would write A/B. So let's see if we can figure out some elements that are in this relation. Well, I know 3 divides 6. So 3 6s in my relation. 3 is related to 6. What about 2 5? Is 2 5 in my relation? 2 does not divide 5, so it's not in my relation. 2 is not related to 5. What about 0 3? Well, this would be 0 divides 3. 0 doesn't, you can't divide by 0, so this is also not in R. But if I flipped it, 3 does divide 0, so 3 is related to 0. You can also look at negative numbers because we're talking about integers here. So for example, -2 is related to 6. So just a reminder what dividing by means here. For all A, B, and Z, A divides B if and only if there exists a K in Z such that B equals A times K. So up here, 3 divides 6 because 6 is 3 times 2. 3 divides 0 because 0 equals 3 times 0. And -2 divides 6 because 6 equals -2 times -3. I can also ask you about the domain of this function. The domain would be all integers. Every integer divides itself. So you would have A is related to A for all A and Z. The codomain is Z because this is a relation on Z. And then the range, well, you said every integer appears in the second coordinate, so the range would also be Z as well.